All right, so scientific notation. There's a reason for it, and there's a reason why we need it. So I'm going to start with this big number right here. So 6.02 times 10 to the 23rd, just to make sure I'm on the same page. We have never talked about this, right? Have we talked about this? Okay, all right. Either way, we're good. So this is Avogadro's number, okay? Have we done this at all? Did you write this down? Okay, all right, we're going to pretend like you've never heard it before. That means you're going to sound really smart when I ask you all these questions. All right, there's 3 rules that I need you guys to know. 3 of them. Number 1, if you have a positive exponent, what does that tell you about that value? Greater than 1. Now, Reagan, I'm just asking to make sure this is you. Did you say greater than 0? Okay. Keep that thought because I want to come back to that, okay? That's a good statement. I want to kind of follow through with that. So that's rule number 1. So my first question, actually, let's go to rule number 2. Rule number 2. If it is a negative exponent, it is what? Less than 1. And then rule number 3. And again, I'm going to let you guys catch up with me. That's rule number 3. Only one number is allowed left of the decimal. Now, that's the most important rule. Yes. All right. So let's look at Avogadro's number and what it is. First of all, I've told you this, guys, before. You know, I just throw stuff at you all the time because we're going to come back to it later. Go ahead and write this. And you can put it in print. You can put it in parentheses or however you want to write it. Equals 1 mole. We'll come back to that. Don't worry about it. Just write it down. I can officially say that you have seen that's true, correct? You now have seen it, so when I say it again, you're like, oh yeah, I remember him saying that, and writing it down. So let's look at Avogadro's number, 6.02 times 10 to the 23rd. Now, does this number match our rule in red? Yes. Okay. There's one number to the left of the decimal. We're good with that. Number 2, which other rule does it now follow? So is this number really, really, really big or really, really, really small? Is really, really, really big. Okay. The way we know that is because the exponent is positive, and so we're going to make it a really big number. Now, Reagan, you said it again. I just want to make sure that everyone's understanding this. I said that if it's a positive exponent, it's greater than 1. If it's a negative exponent, it's less than 1. Why is it compared to 1 and not to 0? Okay. Perfect. Okay. So, if it were a negative exponent, that doesn't mean that the value is less than 0, because what are numbers less than 0? They're negative numbers. Is the whole value negative? No, just the exponent. Is it possible to have negative something to an exponent? Sure, you can have a negative number that small or that big. That's possible, but you rarely ever see it. In fact, I don't think I've ever seen a negative number with scientific notation. But again, in math class, you may run across that at some point or another. Okay? Does that make sense? So here's the reason why we need this. Have I already written this whole thing out? Okay, so I did that yesterday. So the next thing that I want to make sure that we're all on the same page is if I want to write this in expanded form, which means how you would actually physically write it if you had to write the number. If it's greater than 1, what way would I roll my decimal? Okay, move decimal right. Okay. Now, we talked about this yesterday, but logic tells us that if I move it around the 0 and the 2, I can't just quit, because how many total times did I need to move that decimal place according to my exponent? 23 times. I've already moved it how many? 2. So what am I going to add to take the place of all those other movements? 21 zeros. Very good. Does that make sense? Well, we said it. I just want to make sure we're on the same page. So what if our number, did I show you the negative exponent number? All right, so let's look at that one. Okay, this is 9.31 times 10 to the negative 34th. Yeah, write that down. Yeah. 9.31 times 10 to the negative 34. So my first question is this number really, really big or really, really small? Really small, right? Way small. How do you know it's really small? It's negative exponent. Now, really quick, just throwing this at you. You already know that Avogadro's number is equal to what? 1 mole. This is the mass of an, what does E negative stand for? An electron. That's the mass of an electron. Would you expect the mass of an electron to be that small? You maybe not but our electron's really, really tiny. That number is really, really tiny too. Okay? Yes, sir. It's an amount of substance. It's the number of atoms is what it really boils down to. Okay? All right, so we've got this number, and it's really small. If I want to move my decimal to write the expanded form of this number, what way would I move it? Left. I'm going to come back to this page, and I want to add this to the rest of our notes. We're going to say move decimal left. Okay? Now, I'm going to be honest with you. We very rarely work with negative exponent numbers. It's rare, but we do use them occasionally. It just depends on what we're dealing with mainly. But you'll see this in both perspectives. It's even more rare for our numbers to be this large, the 23, or the negative 34. Most of the time, we're going to be working somewhere between the 3 and the 9. Again, it can, but most of the time will be somewhere between there. So let's talk about logic. If I move my decimal point, if I need to move it 34 places to the left, what's the one number I have to go around? 9. So if I move it this way, how many more zeros do I need to add? 33 more zeros. Now, and this is just a teacher-student question. This has nothing to do with this. In y'all's math classes, are y'all allowed to write, and again, this is completely wrong, I'm just saying, are y'all allowed to write it like that? Or do you have to do 0.0931? Do they care? Me personally, I'm begging, I'm pleading, I'm asking, please always write it in that format. And here's the reason why. If I'm looking at your number and you go like this, is there a chance you can't see that little bitty dot? Okay. And if that zero's missing, if it's just, if I can't see it, I think you meant 391, not 0.391. So again, it takes an extra second to put a 0 in front of it. Just please do that for me. It makes your numbers a lot more crisp and understandable. All right, any questions on those things? Okay. The next thing I want you to write down. If you will commit to memorizing 3 things, we're going to add something out. Write them vertical because we're going to add something out to the right of them. Write them vertical for me. Yeah, you don't need a number in front of it because it can be any number, right? That is just times 10 to the something power. Using your thinking skills, if we had to name a number, like you could actually say the name, does anyone know what the name of the number would be if it was to the 3rd power? Very good, whoever said that. So anything to the 3rd power would be something thousand. Now the rest of these two should make a whole lot more sense. What is anything to the 6th power? It is million. And finally, the 9th power is more than likely probably going to be what? Billion. Now, this is just one, I always leave this off. You are more than welcome to write it, but I never do. This is just an extension that I ask. If I went times 10 to the 12th, what would it be? Trillion. Does that make sense? Okay, we're okay with this idea. So here's the deal. If you will memorize these 3 numbers, 10 to the 3rd is 1,000, 10 to the 6th is 1,000,000, 10 to the 9th is 1 billion. anytime you see any number with any exponent that's in the 15-ish range, something to the 15th power, you'll always be able to say it. You can, and I'm one of those that these numbers sometimes confuse me. So if I say the number, it makes more sense, right? If I say 900 billion, that's a lot easier than using scientific notation. Do you agree with that? Because you can physically write out 900 billion. You know how to do that. This is a little bit more challenging. So I like knowing the name of the word, not just the scientific notation. And here's why, if you'll commit to these three, the rest of it makes sense. So do you agree that 1,000, what's the difference between 10,000 and 1,000? One placeholder, right? One movement of a decimal. So if 1,000 is 3, what if you see an exponent to the 4th power? What do you think that's going to be? 10,000. All right, so if we went to 5, that's one less place value than a million. But it's one more place value than 10,000. What would that be? 100,000. Does that make sense? We can go all the way down to the billion. What if you saw something times 10 to the 10th? What would that be? 10 billion. Does that make sense? Okay. What if you saw something times 10 to the 11th? That's 100 billion. So it's a lot easier if you'll just commit to these three. It just kind of makes sense. We're adding everything in the tens places. Does that make sense? Okay. All right, so what I want to do is I want to roll to the next one. Did we do these yesterday? All right. Just write down the first three. I could care less about this last one. Don't worry about the last one. Just write down the first three and see if you can write them in their opposite form. Use the trick that I taught you for the first two. Let's look at the first one. I'm going to show you the long way first, and then I'm going to go back and show you the easy way. So 3.2 times 10 to the 6th. So if I've got 3.2, my first question is that number a big number or small number? How do you know it's big? Positive exponent. So what way am I needing to roll my decimal? Right. Now, logic tells me I've got to go at least around the 2, right? So how many zeros would I need to add after that? 5. Very good. So what I'm going to do is I'm going to erase this little bitty thing right there, and I'm going to add 5 zeros, and I'm going to come back. Is that right? No, that's 4. Sorry. And I'm going to come back in, and I'm going to add my numbers. So 3,200,000. Do you agree that that's a possible way to do it? We could roll our decimal. But if you guys will commit to learning these three things right here. Oop, that's not right. Those, which you can barely see, you would have known something to the 6th power is what? A million. So you could have just written 3, 2, 1, 2, 3 million. You wouldn't have to think about how many numbers you need. Does that make sense? How many of you, and again, I don't care. This is just me learning your style. How many of you would rather move the decimal? All right. How many of you would rather memorize the 3 and base it off of that? Again, your learning styles are your learning styles, and if you look around the room. All right, so let's look at the next one. Yeah, go ahead. Okay, so let me go, actually, let's clear this. So if it's 3.2, do you agree I have to move it 6 places to the right? 6 places to the right because it's bigger than 1. Okay, so 1, 2, 3, 4, 5, 6. There's my decimal point. What do I have to go back in and fill in? So there and there. Does that make sense? Okay. Bottom line, no matter what method you use, if you want to make sure you did it correctly, you can always take that decimal and move it the correct way, how many ever times it tells you to move it, and that will always be right. Okay, that's always your safety net. If you're like, that doesn't look right to me, write it and roll it. Okay, yes, sir. The answer to this question is 3, comma, the number. I need the whole number, not the words. Okay. Now let's look at the next one. It's not reasonable to write that big, huge number like that. In fact, you probably couldn't put that number in your calculator, could you? I don't think it would hold that many places. That's why you couldn't put it in there. But if you learn those 3 things that I've taught you, actually I'm going to show you the hard way first. So where's my decimal point in this number? Because I don't see it. So now you said the end. Which end? The right end. So I'm going to say, all right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 1.0 times 10 to the 10th power. Just out of curiosity, how many of you did that? How many of you actually rolled it? And that's fine. How many of you said, All right? What is the name of that number? How would you tell me that amount of money? 10 billion. All right, well, if you know billion is what exponent? 9. Well, what's 1 more than 9 with a tenths place? So 1 times 10 to the 10th. Does that make sense? You can do it either way, and it will always work. I'm one of those, I like shortcuts. I want to take it easy as possible. So we go on those first two. Now, the bad news is when you go to the negative exponent, there isn't any easy way to do it. You just have to physically manipulate the number with moving the decimal point. Now, Kyron, we'll come back to what you said just a second ago, but I want to answer this one first. My question is it bigger? Is it a big number or a small number? How can you tell us a small number? It's negative exponent. So if I need to make this number smaller, what way do I move my decimal? Left, and how many places? 4. Now, logic tells me I at least got to go around that 0, and then how many zeros would I need to add to it? 3. So 0.123, and then here's my number, 098. So you technically have 4 full zeros in there. Any questions on that? Again, there's not any fancy rules like the other, like positive exponents. You just have to physically manipulate this one. And if you have to write it, I'm just curious. You guys tell me, how many of you would rather write the black number? How many of you would rather write the red number? You don't care? All right. Now, Kyron, you brought up an interesting point. Tell me out loud what you asked me a second ago. So 9.8 times 10 to the negative 5th power. Here's what scares students. I've got 3 different numbers. I've got 0.8 times 10 to the negative 4. I've got 0.000098. And then I've got 9.8 times 10 to the 5th. If I were to ask this on a test and ask you which value is the smallest, guess what you would guess? Most people would say the last one. Why do you think most people would want to say the last one is smaller? It has a higher negative exponent, right? But what is in fact true about all 3 of these, Ralston? They're all identical. I would kind of know that fact. Hint, hint, wink, wink. Okay? And that's where we were going with this. I'm one of those, had I written this number, I would have written it in the blue version. I would not have written it in the black, definitely not in the red. Okay? We want whole numbers, we want real numbers in front of the decimal. Do you agree that 0.98 kind of makes it look a little weird? We don't want to do that. And I'm going to ask this question. Let's see how good you are. The black number and the blue number, actually even the red number. How many of you, thumbs up for yes, thumbs down for no. How many of you say that they have the same number of significant figures in all 3 numbers? Thumbs up for yes, thumbs down for no. They have the same number of significant figures in all 3 values. Okay? All right, how many's in the first one? Decimal point present or absent? Start on what side? The left. Go to your first what? Non-zero, which is 9, and count both of those. Would you agree? The red number, present or absent? Present, start on the left. Go to your first, and I like how you said that. Go to your first real number, which is what? 9, and count both of those. Now, we have not gotten to doing scientific notation yet, but I know what some of you thought. Well, you didn't include this, and we'll talk about that a little bit later, but I'm going to go ahead and tell you that this has nothing to do with significant figures. So same thing here. Would you agree that it's both of those? So we kept significant figures throughout, but we wrote it 3 different ways, and it's the exact same value. Okay, so never be worried about is it the same if you move the decimal the right way. Any questions on that? Go ahead, Jack. Okay. Let me back this all the way back up so all that other stuff is gone. So the way that do I need to answer this out loud? Does anybody else have that question as well? Okay. They're all the same because if I were to write, do you agree that the black and the red are identical because I rolled the decimal out? The reason the blue number is the same is because, watch this. How do I turn this black part into the blue part? What do I do with my decimal? Move it right 1 place. Would you agree? All right. Wouldn't that be like adding one more zero in front of it? So it goes from the fourth power to the fifth power. If I move it one place, I gotta move my exponent with it. Does that make sense? I could actually add one more version of the number, and it's still the exact same. It would be incorrect based on our rule. But if I wrote 98 times 10 to something, what would its power be? -6. So are all three of those identical? Yes. But that doesn't match our rule. What rule does that break? One number to the left of the decimal. Okay? We all go with that. Any other questions on scientific notation? All right. So we're completely shifting gears, and we're going to go to this. Before you write anything down, let me erase some stuff. I want to make it easy as possible. I don't want you to have that. Okay, all right, write all that. I just changed the pen to white, made it really big. So what temperature unit will we never use in here? We'll never use Fahrenheit. Now, has everybody got this written? Okay. Everybody good now? All right, I'm going to clear what I whited out so you can actually see it. And the part that I want you to look up there is in the top in the black. What two temperature units are you converting from there? That's going from Celsius to Fahrenheit, right? If you want to know, which I'm never going to make you do, this is how you would calculate Celsius to Fahrenheit. Okay. Let me ask you this to make sure you're on the same page with me, and I'm going to ask this question again a different way. If we compare Fahrenheit and Celsius temperatures, like if I told you the temperature right now outside was 85 degrees, would the Celsius temperature be above 85 or below 85? Celsius is always less than Fahrenheit, right? Even though they're the same, it's always less than, okay? So same thing with Kelvin. So if I need to go from Celsius to Kelvin, what do? I add. So will Kelvin or Celsius always be higher? Kelvin's always greater. Okay, so keep that in mind, the same thing with Fahrenheit. The next question we're going to get to, and I'm going to show you the question, I'm going to come back to this. The question is, the normal body temperature is 98.6 degrees Fahrenheit. It says convert this 98.6 temperature to the Celsius and to Kelvin scales. So, again, we're never going to do this, but I just want to show you how it would be done. So if we are going from 98.6 degrees Fahrenheit, what would I multiply it by? 9/5 plus 32. Do you agree that that is a pain in your rump to do that kind of calculation? It absolutely is. Now, what would make it a little bit easier other than multiplying it times 9/5? What could you do in the calculator that makes it easier? Go ahead, Ross. Wow, you are totally right. Thank you. My sincerest apologies. I'm an idiot. So 98.6. And again, if you ever catch me in a mistake, catch me, because sometimes I'm not paying attention. This makes it even harder now, right? What would you do first to get the TC? Not yet. Yeah, what would you do to get TC by itself first? Subtract 32 first, right? So let's go ahead and subtract 32, and it would be some other number. And this is the part that I want to make sure that you understand. How do you divide by a fraction? Multiply by the reciprocal. What's the reciprocal of 9/5? 5 nights. And that's why I hate going from Celsius to Kelvin. So we're not even going to worry about that. So what I do want to do is this one. Okay, liquid nitrogen, which is often used as a coolant for low temperature experiments, has a boiling point. I want to stop right here and I want to talk about this word right here. I'm going to ask you the question, and you better not respond with the word point in your explanation. What is the boiling point? It's the temperature, very good, at which what happens. Okay? So always get this every year. What's the boiling point? The point at which something boils? Well, no, duh, you dummy. That's the boiling point. Okay? But what does it mean? It's a temperature, right? You have to look at a thermometer, so it's a temperature. But what's chemically and physically occurring in that water? It's going from a liquid to a gas. That's the boiling point. So if I ask you what the melting point is, it's the temperature at which a solid turns into a liquid. Let me throw this curveball at you. What is the sublimation point? Solid to gas. Somebody get that for me. Does anyone know of anything that sublimizes? It's a solid right into a gas. Can I see that for a second? Dry ice, yeah. If you go to well, it does say immediately, which is fine. Just take this with you, Taylor. And she wrote on, and I wrote on. All right, what were we gonna ask? All right. TK represents temperature Kelvin. Now, I guess I should have said that. TK represents temperature Kelvin. TC represents temperature Celsius. Yeah. You don't have to write. I never write it T sub K or T sub C. I just write C or K. Now, it says the boiling point of liquid nitrogen is 77 K. And it says, what is this temperature? And let's change this to Celsius. So convert 77 Kelvin to Celsius. See if you can do that real quick. 77 Kelvin to Celsius. Go ahead and do that. This should be a really easy conversion. All right, so if I need to get to Celsius from Kelvin, what do I do? No, you're right. My brain was off. You subtract 273. Okay, so what would that answer be? No. Negative 197. Okay. All right, so we've got negative 197 degrees, sir. Kelvins can never be negative, yes. Okay. Now, here's the crazy part. Let me ask you this. We kind of have a little understanding of Celsius. Very basic, but we have a small one. If I asked you this question, what is the boiling point of water in Celsius? 100. Now, this just said that liquid nitrogen does what at negative 197? It freaking boils at negative 197. And water boils at what? Positive 100. So what does that tell you about liquid nitrogen? It's really freaking cold, okay? If you stick your hand down in liquid nitrogen, yes, it will come out like the Harry Potter stuff. You can hit it on something, it will shatter. Okay? It's really, really cold. Called death in your hand. Literally everything would freeze. Okay? Life would not exist anymore for you. So don't jump off into some liquid nitrogen. All right, so again, that's kind of the temperature scale. I'm going to make sure all good on this. I do want to point this out. If for some reason you ever see a worksheet, you ever see a book or something, notice the two numbers on this sheet. It says 273.15. That technically is more accurate, but it's really not going to change your answer enough to matter in the long run. So I just eliminate that 0.15 altogether. Okay? How much time we got left? 3? All right, we'll stop here.